You know, we experience it every single second of our lives, but we almost never actually think about it. It's this invisible, totally essential substance that fuels, well, pretty much all life on Earth. So today, we're going to pull back the curtain and uncover the real composition of the air we're all breathing right now.
I mean, think about it. Air is literally everywhere. We can't see it, we can't smell it, but it fills our lungs something like 20,000 times a day. But what is this stuff really made of? What's the actual recipe? Let's dive in.
Okay, so before we start breaking down the ingredients, let's just set the scene. We all live at the bottom of the atmosphere, and it helps to think of it like this giant protective blanket of gases that's wrapped around our planet. It shelters all life, keeps the temperature from going totally haywire, and even blocks harmful sunlight. It's our planet's invisible shield.
So let's start peeling back the layers of that atmospheric blanket. We're going to start with the two main gases that make up almost everything we're breathing. This is what you might call the 99% solution. So, here it is, the big picture. And it might be simpler than you think. A whopping 78% of the air is nitrogen. Yep, nitrogen. The oxygen that we, need to survive, that makes up another 21%, which means everything else, every single other gas in the atmosphere is crammed into that tiny little 1% sliver you see right there.
99%. Just let that sink in. Two gases. That's pretty much the whole shebang. It seems incredibly simple, right? But this is where the mystery really begins. Because what on earth is hiding in that last tiny 1%?
All right, now it's time to put on our detective hats and zoom way in on that other 1%. You might think, it's just 1%, who cares? But trust me, it contains a surprisingly large and really important supporting cast of characters.
So what's really in there? What other gases are floating around us right now, all fitting into that last little piece of the atmospheric puzzle? And here they are. Okay, I'm willing to bet you might be surprised by this. The biggest player in that 1% is a gas called argon. Get this, at 0.93%, it makes up almost that entire other category all by itself. Then way, way below that, we find much smaller amounts of carbon dioxide, neon, helium, and a few others.
This chart really puts that 1% into perspective. Just look at how argon towers over everything else. Carbon dioxide, a gas we hear about all the time, is just a tiny little blip in comparison. And then gases like neon are just a fraction of even that. It's a real lesson in scale, isn't it?
Okay, so we've got the recipe down. We know the ingredients. But what does air actually do? How does it behave in the real world? Let's talk about its key physical properties, from the pressure it puts on us to how it expands with heat.
All right, let's break down 4 key things about air. First, it's colorless and odorless. Obvious, right? Second, it occupies space. If you've ever blown up a balloon, you've seen this in action. Third, it exerts pressure. Air actually has weight, which is why when you go up a mountain, the air feels thinner. There's just less of it pushing down on you. And finally, it expands when it gets heated. That's the super simple principle behind why hot air balloons float.
You know, I absolutely love this quote from our source material because it's just the perfect way to think about it. The atmosphere is an ocean of these gases. It's such a great reminder that this invisible stuff is real, it has weight, it has density, and all of us are just living and breathing at the very bottom of it.
Okay, for our last section, let's zoom out one last time. Let's take a final look up at the grand structure of this atmospheric ocean we all live in.
So our atmosphere is actually structured into 5 main layers. It starts with the troposphere. That's where we live and where all the weather happens. Then it goes all the way up to the exosphere, which just kind of fades out into space. But here's the really fascinating part. The mixture of gases, that 78% nitrogen, 21% oxygen thing, stays pretty much the same through the lower layers. It's the density that changes like crazy. The higher you go, the thinner the air gets, with fewer and fewer molecules packed together.
So the air all around us isn't just empty space. It's a very specific, fine-tuned mixture that makes all of this, life, possible. This invisible ocean we're swimming in is a precise, life-sustaining recipe. And that leaves us with one last, really crucial question to think about. What happens if that recipe changes?